The tenets of democracy are skills for living in our society that include tolerance, critical thinking and decision-making, thinking together and making meaning, power sharing and empowerment, and individual responsibility and civil involvement with others. More information on this can be found in the Technology as Facilitator of Quality Education model. The teacher creates an opportunity for empowerment by having the students design their own experiments to find out how force, mass, and acceleration are related.
Go look at the materials if you want to that I've laid out. Okay, those are the things that I want you to use. You know about photo gates, you know how to use them. You've got your computer interface, and I just set cars out. There's masses around. If you've got a better plan, do it. But look at those materials. Make your plan. Now you're going to have two things that we're going to be looking for. First thing is a plan. I want to know what you're doing. What are you going to do? What's the plan? Second thing is I need to see what your data is going to look like. How are you recording your data? What are you recording and how are you recording it? And then finally, what are you going to plot or what are you going to graph for me so that we can find a relationship between these three variables? Where are those variables? Two. You need to figure out where they're at.
The students work in groups to design and carry out their experiments. They demonstrate critical thinking and decision-making as they come to a consensus on the data they need to collect and on the best way to gather the data.
Go back, wander around, peek at what I've got there. If you know what I've got there, if you've already looked, that's fine. Peek, get in your groups, move your desks together, make a plan as a group. Who's going to do what? What are you going to do? And let's show it to me and let's go back. Okay? Got about 5 minutes to plan.
Oh, we need that. Card. Oh, we set that up. Then if we just run the cart down the ramp and then have it go through the photo gate, it should tell what the acceleration is.
Yeah. You know, we'll do like a little setup thing.
I have to get some right weights.
A meeting note card.
Hey, Mr. Munson, do we have a note card?
Do we have a note card?
Note card.
Throughout the lesson, the students demonstrate civil involvement with others. They must cooperate with their group members, participating positively with each other in order to complete their task.
Measure in centimeters.
12 centimeters.
No,
But
we're doing
measure it that
this way.
Well,
Get back
this
together, we
is
gotta make sure everybody shares that.
7.5 centimeters.
Okay.
How do you want? How is that?
Uh,
What unit is that in?
.075.
Read it.
See, that is the
think.
genius.
Yeah. That'd be 7.5 centimeters. Because that's in
Is
meters.
it in meters? Okay. So that's good then.
Yeah. Can you close it?
Please don't let it go. You ready?
Ready? So then .069 and 1.07.
Okay?
Want me to do 200 again?
Yeah.
0.0695.
30.
1.07. Okay.
After they perform their experiment, the students work collaboratively to analyze the data they have collected. The students demonstrate thinking together and making meaning as they develop a shared interpretation of the data.
Okay, if we look at the variables, you need to have a relationship between mass and acceleration. The mass goes up, what happens to the acceleration?
Acceleration
Increases. Okay. I can do that.
Do we have that? Do we have that number when we went at the end?
Yeah, our acceleration is going up pretty constant.
Accelerations with force and acceleration. If I look at those two,
It's pretty relative.
okay,
I'm just going to go through nothing.
you're getting what? Something on that order? Curve, straight, what is it?
Pretty straight.
Pretty straight,
About 1 for every 10.
okay. What's going to happen if all of a sudden I start loading weight on here and keeping the force the same? What's going to happen?
Put mass in the car. Acceleration's going to go down.
It's going to go down. So if you talk mass and acceleration, what are you talking about? What kind of shape?
Why don't you write them down?
Hyperbola?
Write them down next.
So you're saying inversely relationship. Jeff, did you do one where you kept the system the same at the end?
Yeah.
Did they change your numbers much?
When we had 150 in the car and 50 in the string, it was .15. When we had 150 in the string and 50 in the car, it was
Okay, if you look at, this is your weight. Your force is going up, what's happening to your velocity, to your acceleration?
Going up,
Going up. So what kind of relationship are we looking at?
direct.
A direct. So if you look at force and acceleration, we're direct.
Yep.
So general shape,
Like that.
something like that. Now, look at your last numbers that we did. When we took the mass, and here we increased the mass of the car, and what happened to our acceleration?
Went down.
Went down, keeping the force. If, in other words, if I loaded a bunch of weight on my, if I kept this the same
Yeah, okay.
and loaded a bunch of weight here, what happened?
Did go down.
Go down. So what's the relationship mass and acceleration wise?
Inverse.
Inverse.
So it looks like you handle the other one. That's what you want.
Okay. Fairly the same. Close.
Yep.